Hello and welcome to our copier and main synthesis lab. In this particular video, we're going to be making dilutions, so we're going to be walking you through our process for that. Our group members are Haley, Samantha, Mckayla, and David, and we're so excited for you to be joining us today. So we're going to go ahead and start by making dilution one. As you can see here, I'm using a pipette, it's called a Moore pipette, to get some of our stock solution into that. We're going to then be transferring that to volumetric flask. Again, the goal here is to get 25 milliliters of dilution one. So we calculated that we needed 12.5 milliliters of the stock solution. So that is what I'm doing right here. And then right here, I'm going to be transferring 12.5 milliliters of distilled water into that volumetric flask. So you can see I'm doing that carefully. We're going to show you some close-ups of the meniscus and all of that for those requirements later on. We know it's a little hard to see right now, but we're going to explain that more thoroughly in a minute. So again, I'm just getting 25 milliliters. And that's just going to be distilled water straight into that uh, beaker. So again, we're trying to go for a 50-50 stock solution. We've got 12.5 milliliters. I'm going to go through those calculations later in the video. So here we're checking the meniscus to determine the amount of the solution was, I'm sorry, as the dilution was close to 25 milliliters as possible. You can see that close up there. We made sure that that meniscus was dipping right where that line would fit. This is me showing you the calculations. Again, I'm going to explain those later on. This is our favorite queen, T.A. Riley. We love her. And we're mixing up that dilution to make sure that it is fully mixed. I'm just putting my thumb over the top and I'm turning it upside down, right side up, just making sure that it's fully diluted. We went on to make two more dilutions. This is Samantha making dilution number two. You can see she's already emptied out some of dilution number one into her beaker, and then she's just putting that distilled water right on top. Again, we're filling to the 25 milliliter line on that beaker. We're making sure that the meniscus is correct. You can kind of see that meniscus goes up right there, how it's curved down, and it hits that line at 25 milliliter mark. This is mimicking dilution number three. Actually, right here, I'm emptying dilution number two into a larger beaker so that we can continue to use that same flask, I'm sorry, that 25 milliliter flask in dilution number three. So Mckayla's going to be making dilution number three. We don't actually have a lot of clips of her making it because our camera died at one point, but we can show you part of it. So this is her kind of starting out and explaining what she's going to do. This is showing a close-up of a meniscus. You can kind of see how I'm going up and down with it. I'm using it to calculate. Again, this is a close-up of a meniscus. This is like our process that we use for all of these things. This is just carefully cleaning all of our glassware after usage. This is after making all three dilutions. So yeah, Samantha is just cleaning those, make sure that they're fully clean to the next. And then we did just quickly explain what a meniscus was. You can see a picture of it on the screen right here. The meniscus is actually referencing the curve down in the water. It's where it's kind of clinging to the sides of the beaker and it's curving down a little bit. Basically, we use the very bottom of that curve to assess where that mark is that we need to fill to. So basically just where it's sticking to the glass, and we use it as a reference for where we need to fill to. Also, side note, shout out Queen Gabby. We also love her. I just didn't get any good clips with her, but we love her too. All right, and then we did just want to talk through some of our base calculations. This is a photo of our lab notebook page. As you can see, we use the base formula C1V1 equals C2V2. Basically, the C1V1 represents the original or dilution 1, whereas the C2V2 represents the concentration and the volume, respectively, of the dilution that we're trying to make. So for the very first dilution equation, we knew that the molarity of the necessary dilution was going to be 0.02 molar. So we went ahead and set that equal to 0.01 molar, which was a randomized selection that we chose. We multiplied that by 25 milliliters, which was the total of that volumetric flask that we were using earlier. So we solved that out and we got 12.5 milliliters of the stock, which is what we used for the first solution. We did the exact same thing, except this time we used the 0.05 molar for the dilution 2, and we solved using the 0.01 molar. We got that because we just divided by 2 based on the 12.5 from the previous. And then finally for dilution 3, we did the exact same thing because we used 12.5 milliliters. We went ahead and set dilution 3 equal to 0.005, which is just 0.01 divided by 2. And then we set that equal to 0.003 times 25 milliliters. Again, that's the total milliliters of the solution. And then again, for all of these, we're just solving for our necessary volume.